I told you guys that there are questions that you can directly substitute values into. Here are some questions like that.
Took a swing at a wrecking ball and I prayed for my downfall.
The limit of x squared minus 4 over x minus 2 as x approaches 3. This would be 9 minus 4 over 3 minus 2, which would be 5 over 1. 5 over 1 would be the same thing as 5. So this is an example of something that you can directly substitute in. The limit of 5x, yes, 5x plus 1 over x, and this is all squared, minus 2x minus 1 over x all squared as x approaches 0. If I substitute 0, this is undefined, that's undefined. 0 times any number is 0, and the same thing happens here. 0 times any number is 0. So what we'll have to do is manipulate. In this case, not much manipulation is needed. As we see, these are both squared, so we'll just expand. Then we substitute 0. So expansion, binomial theorem or Pascal triangle, both are squared, so I'd have a squared plus 2ab plus b squared for both, right? I'm going to leave this here for those who don't recognize this. You can also do it by writing out this. Let me do that. It's better to know binomial theorem or use the Pascal triangle, because if this was a bigger number, then you'll have this going on for a long while. So it's best to know binomial theorem. So let's do this. So first things first, a squared. My a term is 5x, so I'd have 25x squared plus 2 times my a term. My a term is 5x times my b term, which is 1 over x. And since it's 1 over x, I'll just put the x in the denominator. And my b term is 1 over x. 1 squared is 1, and x squared is just x squared, so plus 1 over x squared. That's my first bracket. I'm going to write this smaller. That's my first bracket. Then to my second bracket, if I square my first term, which is 2x, I would have 4x squared. And the same thing. And for the last term, I'd have plus. And the reason for plus, I'm squaring a negative 1, so it will become positive. So plus 1 over x squared. Now I can simplify, just grouping like terms. So I have only 2 x squared terms, so I can subtract because the subtraction sign is right here. So let's do this. 21x squared. 25 minus 4x squared, I'm left with 21x squared. These x cancel, so I have 2 times 5, which is 10. And this cancel each other, right? Now for this term, x cancels x here. So 2 times 2, 4, giving me 21x squared plus 14. So now I can substitute my 0. And I see that if I substitute my 0, I will be left with 14. 21 times 0 is 0. And 0 squared is 0. So 21 times 0 is 0, leaving me with 14 for my limit. So the limit of this function as x approaches 0 is 14. The limit of 2x squared plus 7x plus 3 over 2x plus 6 as x approaches a half. So 2 times a half square plus 7 times a half plus 3 over 2 times a half plus 6. Half squared is a quarter, and 2 times a quarter is just a half, right? So a half plus 3.5 plus 3 over 2 times a half is 1 plus 6. A half is the same as 0.5. 0.5 plus 3.5 is 4 plus 3, which is 7 over 7, giving me 1. So the limit of this function as x approaches a half is 1. Now say this was not a half but negative a half. So I will just negate all the halves. So this would still be half. Negative half squared would still be a quarter times half would still be half. This would be negative and this would be negative. Let me erase this. So now I'm subtracting 3.5 from a half. So I will be left with negative 3 plus 3 over 5. 0 over 5, which would be 0. This is not undefined. If it was, that would be undefined. Dividing a number by 0 is undefined. But 0 divided by a number is just 0. So the limit of this, if it was approaching a half, would be 1. But if it's approaching negative a half, then my limit would be 0. So 1 for a half, 0 for the negative half. Quick short addition to that last video. So I never remember that I never showed you that you can add, subtract, multiply, and divide. Don't know if you would call these principles or what, but this is what I wanted to show you, that you can add, subtract, multiply, and divide limits. And this is what I mean by that. So if you have the limit of a function f of x as x approaches point A, and that limit is equal to f, and you have a next limit, the limit of g of x as x approaches a point A, the same point A is equal to g. The principle, or in some books you may see limit theorem, and this is what it says. So if I have two functions, if I have the limit of two functions and the two functions are added like this, the limit of f of x plus g of x like this. So if you have the limit of this as x approaches A, of course, I can rewrite this as this. The limit of f of x as x approaches A plus the limit of g of x as x approaches A. And all of that will just be equal to f plus g. And the same thing goes for subtraction. So if I'm subtracting two limits, the limit of f of x minus g of x as x approaches the point A, so f of x minus the limit of g of x, and both are approaching the same point A. Now for multiplication, you have two functions being multiplied and you're finding the limit of the two functions. So it is as this: the limit of f of x times g of x as x approaches point A. This is the same thing as the limit of f of x times the limit of g of x, and that will just be equal to both limits be multiplied to each other, and I will represent that with a capital F and a capital G. From here, the limit of the function f is f and the limit of the function g is g. So that is what these are saying. So if you are confused with that, that is what this is saying. The same thing as this part. So the limit of f of x times the limit of g of x, this is the same thing here for those who don't see that. So for division, the limit of a function f of x over function g of x as x approaches point A, this is the same thing as limit of f of x over the limit of g of x, and it's the same thing as if I have this. Remember that, as I said just now, that the capital F represents the limit of the function f and the g is the limit of the function g. I used this one earlier in the example 5x plus 1 over x all squared minus 2x minus 1 over x squared all squared. That example, if you remember that example, then the same thing, I use the same principle here. So I just wanted to show you these. And now for our next one, the limit of a constant times a function f of x as x approaches the point A. This now can be rewritten as this: k times the limit of my function f of x as x approaches point A. K times the limit of my function. Is there any more I should show you? Well, if there is anything else I should show you, I will show you in later videos. So please watch the entire playlist to get the basics of limits. This calculus playlist isn't calculus and all, as in this is based on just calculus 1, really. You may see some things you do in calculus 2. I'm not sure I will do calculus 3. Calculus 3 is deals with multivariable calculus. I will have to do a next playlist for that. So for now, this is it. Thank you guys for watching.
Took a swing at a wrecking ball and I prayed for my downfall.